All right, you maggots, listen up. Now, first thing I'll do, I want to do a quick review of electron current and conventional current. Now, picture Ben Franklin. He's got a table, he's got a bunch of guests around there drinking, and he pulls out a homemade battery and a, a, a bowl of water. It might have salt in it, whatever. He takes two electrodes from the battery, he puts them in the water, and one of the electrodes starts bubbling. And he says, the current is flowing from the bubbling electrode to the other side. Well, he's basically caused some type of like electroplating or some type of reaction to the water. Well, anyway, so for years that's conventional current. Uh, they say the current flows from positive to negative. Well, then the electron microscope came along, which scientists got more involved, and they found out that electrons in the wire go from minus to positive. And then the conventional guys, they said, well, the absence of electrons flows the other way. So you got the empty holes that are moving, if you picture it that way, versus the electrons flowing in the wire. Now a coulomb, was it 68 to the whatever? That's how many electrons pass one point. If you go to school for electronics, you'll find out it's very tedious. There's a lot to learn. But when you go out in the world, you would bump into an engineer, and you got to say to him when you're working with him, you say, "Do you use conventional current?" And conventional current, the arrow on the diode is facing in the direction of conventional current. Electrons flow into the arrow, same with transistors. So you have half conventional current, conventional theory floating around, conventional current theory floating around, and electron theory. So when you're working with an engineer years ago, you would have to say, do you use conventional current or electron current, electron flow? And then he would tell you, and you knew what you were working with. And there were engineers that sucked. They would jump back and forth just to confuse you because they didn't know what they were doing. But I just want to tell you that's the first thing. Now, a few months ago, I did a video and I explained the difference between a short and an open. Now, Shango did the same thing. He basically, a couple weeks after I said it, he went and said, once you get a short and an open in your mind, what it actually is, and you understand that, that's the halfway point to troubleshooting. Right? Now, I just told you about conventional current and electron current. Once you get that in your head, that you could be working with someone that's working backwards from you. Now, I got to warn you, the diode symbol is based on tubes, and it's backwards for electron theory. So your minus goes into the arrow of the diode. It goes backwards. It flows from ground up through the transistors when the arrow is facing down on like an NPN transistor. It can get very confusing because they did fix it. In other words, they got together and they said, let's do it this way. But you still had people out there doing it two different ways. Now, here's one that I want to point out to you, and I didn't build a demo or anything. This is a 6-volt light bulb, and it comes out of a telephone. You know the lights that light up on the bottom of old telephones to tell you what line? That's this, 6 volts. This one's 6 volts. All right, now we take a 6-volt battery. That's exactly 6 volts. 6 volts. There's no such thing. Batteries are a little over on voltage. If it's a 5-volt, if it's a 6-volt battery, it's usually like 6.3, and then when you put it under a load, it might go near 6 volts. But we put exactly 6 volts DC across this light bulb, and we put exactly 6 volts AC across this light bulb. And you say to yourself, 6 volts DC, 6 volts AC. Now, which bulb is going to light brighter? And the answer is they both light exactly the same. It's another one of those fixes. Originally, a lot of electronics was batteries. So when they started switching over to AC generated voltage and transformers, they had to come up with a way, because everybody was dealing with resistors. There were no transistors, there were no tubes. It was strictly voltage dropping. So they wanted the math to be exactly the same for both the DC and the AC. So if you were working with a circuit and you were doing heating or some type of, I don't know what they were doing back in those days, voltage drops, the formula was still the same. It's Ohm's law. You should really learn Ohm's law. I'm not going to explain it to you. I'll let one of those guys in the bow tie on the whiteboard explain Ohm's law to you. I'm a little more practical guy, so I'm going to tell you. So 6 volts DC, 6 volts AC, light, both bulbs light exactly the same. Now, let's go into why. Well, they come up with a way to make the meter movement measure the same amount of basically its power. So when you take a meter, a good meter, and you put it on DC, and you put it across this light bulb, and you read 6 volts, and then you switch the meter to AC, and you put it across this one, and it reads 6 volts AC. Both lights read like the same. Now in the meter, there's diodes, and the way they do it, the way they rectify the AC in order to make DC to make the meter work. Now there are other meters that use thermocouples and hot wires and stuff like that. You can do it that way, but they came up with a way that when you're using Ohm's law for either DC or AC, it's the same. And it was genius. And they call it AC RMS, root means square. And in tech school, when I sat there, I understood it, but 90% of the class never gets it. Right? They never understand it. They never get deep enough into something. Now, they start throwing stuff at you when you're working with diodes and AC. You might have to use 0.707, and you're working with the peak of the AC. And when you rectify it, you get more voltage because the capacitor in the circuit stores some of the energy in between the intervals of the sine wave going up and down. And it's hilarious. You got 0.707 1 minute, 0.1414 another time, and it's like double talk. And the instructor's up there, and he's just going through this stuff. And I'm looking at other guys, and they're asleep. They're just totally gone. And I got into it, and when it becomes important is when you're trying to build a power supply, an old analog supply. The guys, it's a Radio Shack story. Guy gets a power supply in from a customer, and he drills the rivets out, and he opens it up. He takes the transformer out. He goes over, and he gets a 12-volt transformer off the wall. He puts it in there, and it's a CB power supply, and he's not getting the 13.8. So he comes up to me, and I said, yeah. I said, a 12-volt transformer off the wall, that's 12.6. It's for filaments. He's staring at me with that bird brain look. I said, that transformer is for lighting a filament of a tube. The 6-volt transformers are 6.3. They're for 6.3 volt filaments. Has nothing to do basically with transistor circuits. You can use them to make a power supply, but you're never really going to get the voltage you really want. So say you take a 6.3 volt transformer with a center tap, and you use 2 diodes with a capacitor. I believe you get the 6.3 gives you about 9 volts. Under load about 9 volts. The 12.6 one gives you more than you want for CB. It gives you like 18 volts. So this guy is like, well, what do we do? What do we do? So I said, all right, where's the transformer you took out? And he gives it to me, and I cut the outside paper of the transformer. And he goes, what are you doing? I said, there's a fuse in here. What? I said, I have experience. Trust me on this one. So I go poking around, and you peel the paper back on the transformer that came out of the Radio Shack 13-8 volt supply. And there's a little piece of wire. I say, see this piece of wire? This is a fuse. And I show them, in those days, I used to strip a piece of electrical wire, lamp cord, and take a couple of the strands out and twist them together and make up approximately that thickness and solder that in there. That's the fuse. It's a fusible link. And then the guy puts it on, and now it all works. And what happens is, the guy will hook the power supply up, and he'll do something stupid like put the polarity backwards and blow the transformer fusible link out. The fuse in the power supply never seems to blow, and it's hilarious stuff. And I'm dealing with this guy, so now I show him how to fix the power supply. Now the other thing is power adapters. Same thing. You know those wall warts here? Let me show you one. Let's put one of these in the frame. Now, if you lay one of these on the cement floor and you hammer along here, see this? This is where it's fused together. All right, all the way around it's fused together. It's not glued, it's fused. And you're going to say, what? Yeah, there's a tool that you put on here and it vibrates at a high frequency, and it gets this plastic molten and it sticks together. This is fused together. It's not glued together. So you lay this on a cement floor and you hit this with a hammer right here. Bang, bang, bang. Gently first. Bang, bang, bang. Then the other side. And then to get this one, you have to put a metal block down on the bottom here, and you hammer along the top. And you'll see it cracking. And then you get your screwdriver and you work it open. And inside you'll find a piece of wire that's burnt away. It's a fusible link. You put in a wire that same thickness, the same length, and the power adapter will start to work. That's it. You fixed it. You didn't have to go find another one. And then sometimes, of course, the wire that goes to the plug gets a break in it. You know, dog has chewed it. The wife has caught it in a drawer. I've fixed so many things in my lifetime, and most of it, 95% is because people are stupid. You're not fixing something because it went bad and a component failed and somebody did something stupid to it. Well, I was trying something. Yeah, you know electronics. You were trying something, but I just wanted to throw out there the AC, DC, and there's other things you got to learn. But the first thing you want to learn is understand the difference between a short and an open. I explained that to you. Now, the next thing you want to understand is electron current, electron flow, whatever you want to call it, from minus to positive, and conventional. A lot of your symbols of solid state are in backwards because it's conventional. And you go into it and you never, there's people that never put the two together. And I told you, I worked with engineers that would get confused as they were explaining something to me. And I knew they would switch back and forth from conventional current to electron current. I'm probably messing this up, but anyway, to hide the fact they got confused or they didn't know what they were talking about. It's funny stuff. And then to understand DC and AC and how you turn AC into DC without it being a switching supply. It's very important if you're going to do experiments to understand that the transformers that you can buy, they're really filament transformers. And then you got to pick one that's slightly close enough to what you want to do. And in some cases, you're going to have to put a regulator in there and go with the bigger transformer, more voltage, and then regulate it down. That's the stuff. And they never, and when you buy a radio, that transformer is usually custom. And that's how they do it. They make a custom transformer. So they can come into two diodes. Usually a good transformer has 3 leads on it. And you can use a full wave bridge, which only needs 2, but the best transformers have 3 leads. One goes to ground, and then you have one that supplies to positive, and then the other side also supplies to positive. The 2 windings are out of phase, So they provide you with full wave rectification. That's the other thing you want to understand. Half wave rectification and full wave rectification. And that's why you shoot for a transformer with 3 leads at the right amount of voltage, because it gives you full wave rectification with just 2 diodes. And it'll give you more current. When you use 4 diodes for a full wave bridge, you get drops in those 4 diodes that you might not want. You get the voltage you want, and as you're loading the supply down, the transformer's doing okay, but the 4 diodes that's giving you full wave rectification, you're getting drop across those diodes, and you're losing voltage as heat. So there's so much in electronics to learn. I'm just showing you sort of the funny things I realized that other people didn't get the concept, and I'm trying to explain to you in a simple way. The guy going over to the wall and getting a 12-volt transformer and sticking it in a CB radio power supply that's really 13.8. And 13.8, you're like, well, what's 13.8? Well, that's the amount of voltage you put across a car battery to charge it. When you got 13.8 across a 12-volt car battery, it's taking full charge. You're like, what? Yeah, funny stuff, huh? A 12-volt car radio is 12 volts. When it's sitting still, it's about 12 volts. During cranking, a good battery with a good starter goes down to about 9 volts, maybe to 6 if it's a big engine. And then when the engine's running, idling, you put your meter on your battery, and it should be more than 12 volts. It should be taking a charge. And then you put the headlights on in your car, and that loads the battery down, and you see if it drops below 12. If it drops below 12, the alternator could be bad, or the belt could be slipping. See, I've been down these roads, and that's why go get John, go get John, go get John. I had no real life. It was electrons 24/7. But the one problem was when nobody was bothering me, I had my nose in books, in circuits, and I can go up to anyone and start a conversation because I've read on all subjects. But I like dating, terrible dating. Go out with the girl, and the girl just seemed like she's on another planet to me because I have a different logic set, and it takes an adjustment time. And women want different things than you want, and they want to be told they're good looking. They want you to buy food, buy them dinner, take them to a movie. You're supposed to be impressing them, and I'm like, at some point, I'm like, fuck this shit. I'm not kidding you. I'm thinking to myself, I'd rather be home building a circuit, because there's a lot involved. Now you get married, you have kids, you got responsibility, and you never really got to do what you wanted to do. And I worked with guys like that. They would come over and stand next to me, and they'd go, "You're so lucky you never get married. You have no idea." I said, "Yeah, I do have an idea, because you're not the only person that stood next to me and told me how bad marriage is. You're not, you got the cat by the balls. You got the tiger by the tail." And then at some point they started figuring out, what happened was some girl, I went to this bank, and it was only one of my banks. And the girl went and squealed to her sister how much money I had. And then suddenly all the women at work that ignore me were suddenly friendly with me because he only went to tech school. And then someone says, "You know how much money he has?" At some point, I was worth over $500,000, and then I quit working. And I used that money just for paying bills and food. And it doesn't go real fast. If you're real careful, let's just say I whizzed through over $250,000 in 20 years because I had some money coming in from the booklets I was writing. I was using my savings. Also, my savings were being used for research and development in the CNC stuff. That was the mistake. I put money into stuff that people would just keep hitting my website to see what I was doing, and then they would just copy it. Or they put free stuff up on the internet. I won't go into that. It was very bad. And I would pay money to do the research and development. and find out what materials from the hardware store I could make a good CNC machine out of, and then write a booklet and sell the booklet. And other people were just copying. That's what you don't realize this when you go into something. You think people are going to like you, and they're not. They're going to be jealous of you. And the same with when I was getting up to 1,000 subscribers a few years ago. I had trolls start showing up, and I would click on their name or picture. They didn't have any videos. They would get jealous of. So this time I handled it different, and I got to 1,000. And you notice I make fun of someone will make a dopey comment and a nasty comment, and when I do my next video, I put that in there because when someone abuses me, I abuse them back because I can. I think that's it. All right, that's it.